Okay, I want to look at a couple more examples here. Now, in this example, we're looking at absolute value equations that involve rewriting. So the idea is, like this example here, you have absolute value of x plus 5 minus 2 equals 12. Now, we cannot just start setting this problem up as it is. We need to get the absolute value expression by itself on one side and take all the other terms over to the other side. So the first thing we will do here is start out by moving this negative 2 over to the other side so that we can have the absolute value expression by itself. And that will give you absolute value of x plus 5 equals 14. And now we can go ahead and start solving this expression. So again, remember, when you're saying absolute value of x plus 5 equals 14, we're saying this expression is 14 units from 0. So we will set this up as x plus 5 equals 14, or x plus 5 equals negative 14. Move your 5 over to the other side, and you end up with x equals 9. And for the other side, you will end up with x equals negative 19. And again, you can check your solutions to make sure that both of them work. And your solution set is going to be negative 19 and 9. Just two numbers that will satisfy your original expression here. Now you can also see some absolute value inequalities that may involve rewriting. So let's look at an example where you may come across something like this. You have absolute value of 6x minus 1 minus 2 greater than 6. Again, you can see the absolute value expression is not by itself, so we will start out by moving the negative 2 over to the other side. So add that to both sides, and we end up with absolute value of 6x minus 1 greater than positive 8. And once you set it up this way, now you can go ahead and solve this problem. Now again, since this is a greater than inequality, it tells me my compound statement will be an OR statement. So you have 6x minus 1 greater than 8, or 6x minus 1 less than negative 8. Alright, so let's solve these two inequalities here. And you end up with 6x greater than 9. Divide everything by 6. And that gives you x is greater than 3/2. On the other side, move your 1 over. You have 6x is less than negative 7. Again, do the same thing. Divide everything by 6. And this time you end up with x is less than negative 7/6. And since you know this is an OR inequality, which means you're going to have a union of set in your answers, if you try to graph these, you're basically saying x has to be greater than 3/2, which will be all of these values here, not including 3/2. And on the other side, you have negative 7/6, x being less than negative 7/6. So somewhere here, you can have negative 7/6 and all the values less than, not including the endpoint. Okay? So when you write this as a solution set, you will write it as all the values between negative infinity and negative 7/6. Again, not including negative 7/6, and the other side you have everything greater than 3/2. So that is 3/2 to positive infinity, not including 3/2. And then you use your union symbol to join the two intervals.